Hello there, everyone. My name is Jimmy Mack, and welcome back to the fifth academic podcast. This is going to be a bit of a weird one. I'm just going to be going over random general knowledge stuff that you should probably know going into Super Bowl. To start off with, let's talk about Maslow's hierarchy of needs. This theory basically determines how people value things, and as people fulfill their needs on lower levels of the hierarchy, they move up to trying to satisfy the higher ones. So you start off with your physiological needs. You need to have enough food, you need to have water, you need to have warmth to survive, etc. Then you have safety needs where you need to feel secure and that you will continue to fulfill those physiological needs. So that's like shelter, or like a continued food source, or like a job or something. Then you have belonging needs, where you need to feel affiliated with others and to feel accepted. Then you have esteem needs, where you need to achieve and be competent. You have cognitive needs to continue to know, understand, and explore. You have aesthetic needs, which is just an appreciation for symmetry and order. And then you have self-actualization needs, which is the achievement of all you can be. And in that order, those are the hierarchies of needs. Next, we have the theory of situational leadership. Now, this theory posits there are a couple of different states that your followers can be in as a leader, and you have to manage your leadership style accordingly in order to adjust for the situation. The first situation your followers can be in is called Readiness Level 1, or R1 for short, in which they are both unable and unwilling to perform the task at hand. And this requires that you supervise them very closely using the telling style of leadership in order to micromanage what's going on. Now, as they become more accustomed to the team, they might still be unable to carry out the task at hand, but they can become more willing. This will move them to Readiness Level 2, or R2. As a leader, what you'll have to do is shift to the selling style of leadership, in which you get them a lot more involved in the project, but still make sure that you're keeping a close eye on them. Because they're more willing, you don't have to micromanage them as much, but because they're still unable, you still do have to focus a lot on how they're doing the work. Now, at Readiness Level 3, or R3, the followers are able to carry out the task at hand, but they are unwilling to do so. This requires that you shift to a participatory leading style, in which you engage with the group in order to make sure that they're doing what they're supposed to be doing. And finally, we have Readiness Level 4, or R4, in which the followers are both able and willing to do the tasks assigned to them. This allows the leader to use delegation and simply assign tasks and trust the followers that it'll get done. Next up, there's some basic physics that we got asked a lot about on the Marietta Mesa test. So, mass is a property of all matter. The force that gravity exerts on matter with mass is called weight. Mass is measured in grams or pounds, whereas weight is measured in newtons or pounds force. Yes, the imperial system did just use pounds for both mass and weight. I mean, it also has a unit for weight called a stone, but that's equal to like 14 pounds, and that's really weird, so no one actually uses it. Thanks, imperial system. Anyway, when objects take up area, that area that they take up is called volume. And mass per volume is called density. Now, something with a lower density, like say a ship, will float on top of something with a higher density, like water. This is why our ships float, is because they have a lower density. Now, Jimmy, you're probably thinking, aren't all our ships made out of steel? And isn't that, like, really heavy? And the answer is yes. But you also have to consider that there's a lot of empty space in the ship, a lot of air. And air is very light. But because the outside of the ship is coated in a hull, it still counts towards that volume that the ship takes up. I mean, there isn't any water in there. So, because the volume of the ship is a lot greater than just the steel, its density overall is lower, and so it can float. So, I mentioned before that less dense objects float atop more dense objects, but that's not entirely true. The way it works is that the more dense objects are pulled down harder because they have more mass per volume, and so, as they're being pulled down, they push the less dense object up, and that force is called buoyancy. Now, we've got two forces that we're talking about, gravity and buoyancy, and each has their own center. The center of gravity is the center of masses of the ship, which is where gravity seems to be acting from, averaged across the ship. The center of buoyancy is like the center of gravity, but it's the center of specifically the position that's underwater. Now, because the center of buoyancy is below the center of gravity, when the ship starts to roll, the different part of the ship is underwater, so the center of buoyancy moves in the direction that the ship rolls. And what we get is called a torque, which is a rotational force, and that torque is called a righting arm that will push the ship back upright as it rolls. Now, you might be thinking right now, hey Jimmy, that's fine and dandy, but what about submarines? And to that I'd respond, what about submarines? They operate on exactly the principles that I've outlined earlier. They're just a lot more clever about it. You see, ships, we can just make them really lightweight per volume, and then they'll float up really nicely, and that's all well and good. But for a submarine, we need to be able to control it. We want it to go up and down, so that means we need to be able to control its density on the fly. And so what we have are fillable water tanks called ballast tanks. And so when we pump water into them, that adds more mass to the ship without changing its volume, raising its density and causing it to sink more. But then we can pump the water right back out of them, and it'll replace it with air, which is a lot nicer and lighter, so we'll have less density and the ship will float upward. And by carefully controlling the amount of ballast in the submarine's tanks, we can control whether it goes up or down using just the principles of buoyancy that we've talked about. Now, you all know basic physics, force equals mass times acceleration and all that, so I'm going to keep it pretty short. Main thing you need to know is that velocity is the change in position over time, and acceleration is the change in velocity over time. That's pretty simple. Just make sure you're reading the questions really carefully so that you don't accidentally get mixed up and misinterpret something. Dean. Anyway, that's about it for today. Thank you all so much for listening, and I'll see you tomorrow.